Okay. Good morning. Can you hear me? Can you see the slide? Okay, boleh dengar? Anyone?
Yes,
Boleh,
sir.
can sir, boleh.
Okay, so boleh tengok slide. Okay, so while waiting for your friends, I think I'll just go through. Okay, so previously kita stop dekat cushioning of the cylinder. Okay, so I will just brief through lah. So what is cushioning about? Okay, cushioning is actually how to say? Okay, so cushioning of cylinder bermaksud, so you are doing a simple mechanism to prevent a sudden damaging impact. Okay, that is what we call as cushioning. Kalau yang still masuk, so, kalau boleh tu try to masuk sebelum pukul 10. Yeah, if not, the message keep on coming. Okay. So kalau you tengok dekat sini, so you have at the end position, so you have a cushioning piston. Okay, so to direct flow path. Okay, so you are taking the air in order to control the to provide cushioning. Okay, so kalau you tengok dekat sini, so here the air is going out. Okay, dekat sini cushioning is not happening, but once your plunger enters the cap, okay, so dekat sini, so udara yang ada dekat sini will try to escape. Okay, will try to escape through the undisrupted part. Sebab dekat sini dia macam dah alang, dekat sini pun dah alang. So dia akan cari jalan yang tak ada alangan lah. So tak ada rintangan. So it will try to escape through here. So it depends on this opening. Okay, so kalau ada udara yang masuk dekat sini, so what it will happen, it will slow down this movement. Sebab dia bagi laluan lah. So laluan VIP. Okay, so this will have a more priority sebab tak ada rintangan. Okay, so the only thing is tak ada rintangan. So when the kawan-kawan you baru nak masuk. Okay, so when there is no obstruction ataupun restriction, udara akan prefer to lalu this way. Okay, so that's how the air cushioning is happening. Okay, so then you see the comparison. I think you are familiar with single acting cylinder and also double acting cylinder. So I think you pun dah buat lab. Okay, so single acting cylinder always with spring and double acting cylinder without spring. You boleh tengok single acting ada one port, double acting ada dua port, and it's only doing work in one side. The return is based on spring, mechanical. Tapi untuk double acting cylinder, both way kalau you nak extend ataupun retract, you need to use compressor. Okay, so boleh baca dekat sini lah. Okay, just try to summarize. Yes, cylinder construction. You can see here, these are the basic part of cylinder. So yang ni bahagian piston, yang ni bahagian rod. Okay, so you have a body, so you boleh tengok dekat sini. So all the seal. So what's the function of seal? Yang ni idea? Kenapa kena ada seal?
So the pressured air doesn't escape.
Yeah, so the compressor doesn't escape. Okay, so seal maksudnya untuk tutup lah. So nama pun dia seal kan. Seal is to seal something, so to prevent something. So you are preventing the compressed air to, sebab dekat sini ada dua chamber. Satu bahagian sini, dekat sini ada udara dipisahkan oleh the piston, and here you have another room. So you don't want the compressed air from this room to escape to this room. Nanti your cylinder will not be efficient. So you put a seal so that it will prevent the air from escaping. Okay. Tapi you tengok, dia memang ada banyak seal lah. So dekat sini ada rod seal, dia ada piston seal, kemudian ada well and seal. So it depend. So based on the location, you tahu lah. So what will be the function? So wiper seal. So dia macam nak kurangkan udara tu escape. Okay. Then you can see yang ni adalah base cap. So ada bearing. So bearing is for smoothen the movement. Barrel adalah bahagian yang panjang lah. Okay. So these are actually 5 basic part of cylinder. Dia ada dua end, dua end cap, satu base cap, yang ni adalah bearing cap. Kemudian ada dua port. Okay, yang ni dua port kalau is a double acting cylinder lah. Ada input, ada output port. Okay, ataupun extend and retract port. Kemudian ada piston. Okay, so ada piston, ada rod. Okay, then ada seals. Other seals pun ada. Then you have a cylinder barrel and bearing and etc. So this is a construction of a typical cylinder. And selalunya akan ada soalan lah dari bahagian ni. So quite famous juga. So normally we will give this diagram and we will ask you to label ataupun buat list down. Okay. So graphical cylinder symbols. So based on the symbol, you suppose boleh bagi explanation ataupun nama. Okay, so that's a very important thing. So you boleh tengok, I think the explanation is given. Based on that, you boleh tahulah apa yang ada. Okay, so mounting techniques. Apa tu mounting? Siapa boleh bagi tahu? Mounting, what is mounting? Anyone?
Itu like you attach the thing onto something.
Okay, so you have a cylinder, you want to fix it at one point, so that it won't move, or it has some certain move. So we have 3 types of mounting techniques. It's not only 3 types lah, tapi these are the common one. Satu adalah center line mounting. So you have a piston, so piston is moving to the sides, horizontal, and you have a center mount. So you mount, so basically your piston will be horizontal. So you boleh tengok ada center line. Center line, so you are mounting this to a particular place lah. Okay, or particular arrangement. So you boleh tengok dekat sini. Okay. Fixed centerline mounting. In this mounting, the cylinder is supported along its support line. So ini adalah center line. So center line of the cylinder is at the dekat sini lah. So you put the mounting. So you boleh tengok ada dua paku dekat sini. So you are mounting straight. So kalau your surface is flat, dia akan menegak lah. your cylinder. So you are directly attaching it to the surface. Yang ni adalah push type, ini adalah pull type. So practically from the surface, your cylinder will be straight. Okay, so that is a fixed centerline mounting. So you need to have an accurate alignment. So kalau silap alignment, so dia akan pergi push dekat other place because it's not flexible. Then you have a flexible one. Okay, so you ada pivot centerline mounting. So you just clip at the center of the barrel. So you have the barrel, so you letak dekat center, so it can move upward. Okay, so it will have some rotational degree of freedom lah. Okay, so dia boleh bergerak atas dan bawah. Okay, so you try to imagine. So I can't really show. Kalau dekat lecture, face to face lecture, I boleh tunjuk lah macam mana. Okay, so you just like clip at the middle, and it can move upward and downward. Okay, then you have a fixed non-centerline mounting. So you at this you ada surface dekat bawah ni, then you have paku. Okay, at the side. So practically in the side mount, your cylinder will be flat. Dia parallel dengan surface. Yang ni dia not parallel, dia normal. Kita panggil as normal lah. Okay. So yang ni adalah parallel dengan surface. Okay, so these are three famous ataupun common mounting techniques. Okay, so you boleh tengok dekat sini. So it's all based on the same thing lah. So different types of fixed centerline mounting. Tengok. Dia ada. So this is actually way dia lebih kurang lah. But mostly it will be normal to the surface. Yang ni maybe different kind of fixed central line. Tapi for me it's more like fixed non-central line lah. Maybe yang ni boleh letak dekat sini. Because it's parallel to the surface. Maybe kalau surface tu at a different place, maybe it can be a fixed central line lah. Tapi since kalau dekat bawah ni adalah surface, so it will be fixed non-central line. Okay, and this is a pivoted central line. So dia ada some degree of freedom untuk dia bergerak. Okay. Then cylinder force, velocity and power. Okay, so ini adalah kawasan yang exposed. So it depends on the cylinder also. So you are calculating because it's related to fluid. Our fluid for pneumatic is compressed air. So compressed air dia ada force, dia ada velocity, and it has its own power. So katakan you nak cari untuk extension. So if you want to extend this, so you need to consider the area of exposure. So yang ni dibulat selalunya piston. So if you have a compressor entering the blow, so the area of exposure will be the entire piston area. Sebab dekat bahagian belakang ni tak ada rod. So dia akan kena dekat semua. So it will be the entire piston area AP, the area of piston. So it will be subjected to the compressed air pressure. Tapi untuk retraction, you supply dekat sini, so you need to minus the area of the rod. So AP minus AR, piston area minus rod area. So you kena minus. Baru you boleh calculate. Tapi calculation untuk pneumatic and hydraulic not much. So these are the formula that involve okay untuk force and also velocity during extension. So yang ni dia based on this condition lah. Push type piston. Okay, so velocity of extension, uh, the inflow rate divided by area of piston, you akan dapat velocity of the extension. And if you want to calculate the force of extension, so pressure times with the piston area. Okay, untuk retraction, so you need AP ni you kena ganti minus dengan AR. Because for retraction, you don't you need to minus the area of rod. Okay, untuk force pun sama. Okay, so practically the formula are the same, just the area. Area ni yang berbeza untuk extension and retraction. Okay, untuk power, okay, since we are using a pneumatic power, so both side will have a power, okay, and the power will be the same. Okay, so power will be the same lah. Okay, okay, so based on the calculation dekat sini, so you can calculate the power. So power is force times velocity, FV. The force times velocity. So you can do conversion. So using all this conversion rate. Okay, so VP, so velocity of the piston times with force. Okay, force we boleh calculate dekat sini. Or you can use Q in mass flow rate times with pressure. Okay, so power during extension. So yang ni macam tadi lah. So the only difference will be area of piston. Untuk extension dia kena semua. Untuk retraction dia kena minus with AR ataupun rod area. So comparing equation A and B is practically the same lah. Sebab kalau you boleh cancel, you can cancel here. So it will still P times Q in, pressure times Q in. So walaupun dia ada you difference in area, but at the end you still get the same. Sebab tu I cakap tadi, so the power will be the same. Okay, so you can try this example. So I think maybe you already try this lah, kan? So based on the at puzzle video, so I'm not going through this. I just going to straight to. So boleh tengok. So LPM adalah liter per minute. Okay, so liter per minute. So you can have other conversion. And at the end, you need to calculate the force in Newton. Okay, so try to go through this. I think at times persoalan macam ni pun boleh keluar. Because since for pneumatic and hydraulic, we don't have a lot of calculation. So yang ni I chance untuk keluar lah. Okay, so whenever it's required. Okay, so then we move to rotary actuators or motors, okay, whichever having a rotary motion. So dekat sini, so rotary actuators are used to achieve angular motion. The angular motion meaning rotation lah. Okay, so you have some with limited. So normally rotary actuators will produce high torque output. So torque meaning the turning effect of force, and you Normally, we will have a limited rotary movement. It can be either 90 degrees, dia boleh rotate 90 degrees, 180 degrees, 270 ataupun 360. And you can have also unlimited angle. Okay, continuous. Boleh juga. Okay, so you have a few. So vane type, limit rotation motor. Okay, so you have a single vane and double vane. Then you have a rack and pinion type, and you have a helix spine rotary actuators. Okay, dalam video tu memang ada explain. Okay, so single vane. So meaning it's only have one side. Yang warna hijau ni dia cuma ada one side. So air is entering through A, so it will push this thing. Starting from here, it will push until the stopper dekat sini. Okay, so you have two stopper. Then if you want it to go back to the other side, so you supply from A B lah. Okay, dia tukar tempat. Okay, so because of the stopper, so it can go maximum from here until here 270 degrees. Okay, so that is what we call as single vane limited rotation actuator. And you have a double wing. You tengok ada dua ni. And you have a two stopper. So meaning you have four space. Dekat sini satu, dekat sini satu, dekat sini, and also dekat sini. Okay, so you can see the air is entering here. So udara masuk dekat sini and it will go here and enter here. Okay, so both will move together. Tapi the only disadvantage is sebabkan stopper ni, so it only can move until 100 degrees. Macam tadi 270 degrees, so this maximum can go up to 100 degrees. Sorry, 100 degrees. Sudut. Okay, then you have a rack and pinion. Okay, so apa function rack and pinion? Anyone? Rack and pinion, so what's the function?
Dragon pinion to turn and move the piston.
Okay. So rack and pinion, normally what it will do, if you see this is in the linear ataupun flat lah, and you have a rotation. So rack and pinion, it will help when you rotate this, it will change the direction of something from rotational to uh, linear ataupun linear to rotation. So these are the things that always available in in your car lah. Dalam kereta pun ada kan banyak. So you have a wheel. Wheel is rotating in a rotary movement, tapi kereta bergerak in a linear. So it's because you have rack and pinion in your car. Okay, so similarly, in pneumatic you can do this. So you can have a standard rotation angle of 90 to 180. So when you rotate this, your piston will move. Okay, so rack and pinion type of rotary actuators, you are converting a rotary movement to linear. Okay. Then you have a helix spine rotary actuators. So you can see here you have like a screw. Okay. Then you have a hollow rod. So meaning this is fixed. Okay, so this is non-rotating. The one that will be fixed will move is okay, so when you are supplying airflow if you want the shaft to turn clockwise, so CW is clockwise and CCW is counterclockwise. So if you want it to move, okay, so you just need to supply here and this thing will move. It won't rotate, but it will move, okay, left and right. So when you supply the air, it will move and it will turn the screw. And this output shaft will have a clockwise, equal arah jump. So if you want it to turn counterclockwise, so you supply air here, and it will move this side, and it will rotate counterclockwise. So that is how you are using helix spine rotary actuators in order to move your uh, anything that related, and the maximum angle of rotation can be 360 sebab they ikut panjang screw. Okay, so always the screw will be enough to cover 360. You still can extend this thing if you want more, tapi it cannot be continuous. Okay, so it somehow will have a limit. Okay, then you have a air motor or pneumatic motors. Okay, so air motors will be very helpful lah. Okay, so especially in the automotive industry, you can see this in the car workshop or motor workshop. So you always will have like a drill machine, screw, driver, grinding. Uh, so you are using compressed air in the car workshop to unscrew ataupun screw nut, uh, ataupun drill ataupun grind. You can use all that. Okay, so the advantage of air motors, so there's a flexible motor control. Okay, so I talk because compressed air, so it can be powerful for automotive industry. It can produce I talk. Okay, so easy to control the direction. Okay, so unlimited angle. Okay, so safe to use in flammable area. Di tempat yang mudah terbakar. Okay, so it will be useful. Okay, like automotive industries, so you always will see oil everywhere. So it's considered as a flammable area. So it's safe to use air motor or pneumatic motors. Okay, so type of air motor you can use have piston motors, sliding wheel motors, gear motor or turbine. So these are the example of air motor that you can see in the workshops. Okay, yang ni you sambung dekat compressor and you'll have a reduction gear everything and the motor will move. Sama lah dekat sini. Okay, so that's all from the slide. Okay, so any question from the slide? Anything that you want to ask?
Sir,
Yeah.
so we looked at the helix spine rotary mode actuator, but I still don't understand or see how the helix spine thing works. Can you please explain?
Okay, so helix spine. Okay, can you see this slide?
Yes.
Okay. So if you see here, so this is a non-rotating part, and but it will move from left to right. Okay, in your piston body. Okay, and you have a screw. Okay, when you have a screw here, so this is a moving part. Okay, so if you move this thing, okay, when the so let's say you want to move the output in a counterclockwise, so you supply air here. Okay, when you supply air here, so this thing will move. Okay, so the air will start to push this, and it will move to your uh, your left. So when it moves here, the screw is attached to the hollow rod. Okay, so hollow rod meaning so kosong dalam ni. So your screw is entering inside. Okay, so dalam ni dia ada the thread lah. Okay, for the screw. Okay, when it moves, so when it moves, it will convert the movement will convert uh, from a linear to rotary. Sebab dalam ni dia ada thread dia lah, thread of the screw. So the screw will start to rotate. Yang ni dia connect dekat shaft, so shaft ni akan berputar. Ni is for counterclockwise. Faham tak? So this thing when it move here, while it move, it will rotate this screw also. Kalau tak dia tak boleh pergi ke sini kan sebab dia ada track. So if you want to move here, it it will force this thing to turn as well. Baru dia boleh bergerak dari sini ke sini. Faham tak?
So it's kind of like a screw in a hole situation.
Yeah.
Make it bounce.
So the screw will be moving when this thing move. When this thing move to left or right. So similarly, if you want it to the shaft to turn clockwise, you just supply at the clockwise port compressor and this thing will move to the right and this screw will start to turn clockwise. Okay. Okay, so any more questions from the slide before we go through the questions in Edge Puzzle? So you don't have, so I will open the Edge Puzzle. Okay, can you see the Edge Puzzle? Okay, so
Yes, sir.
today is supposed to be a due date, but I think so many people not sent yet. I don't want to show the student name. Okay, but I can show if you want. Okay, so I see like so many people not yet submit lah. Okay, so you have time until today. Okay, please submit, and I will consider it as a synchronous lecture attendance. Okay, so there we have a few questions here that for you to answer. Okay, how cylinder cushioning is done in a piston? Anyone? How the cylinder cushioning is done?
It's done by forcing air through a nozzle and then the reduced pressure will cushion the impact.
Okay. So can you see the entire screen?
Yes, sir.
So can you see the slide?
Also, yes.
Okay. So I will show you. Okay, so this. So if you want to read, I think I suggest you to read. But cushioning of cylinder is for you to prevent sudden damaging impact. So you are utilizing compressed air. You channel the compressor in such a way that it can be used to slow down your piston. And when you slow down, it will prevent the sudden damaging impact. Yes. So macam mana dia buat? So if you see, okay, so you refer to this. So this is your piston, and you have uh, a rod lah. A rod ada, so you have like at the back of your piston. So normally you will have like this, and you have your base cap. Ni yang kita panggil as base cap. So dekat base cap, you ada some screw and also one-way flow control valve. Okay, so what you'll do, you ada dua chamber. Okay, because your piston separate dua chamber. So when compressor enters here, it will push this side and your piston will start to move to your left. Okay, so dekat sini, udara yang ada dekat sini will escape. So since here no blockage, so dia akan escape through the main door lah. The main door dia akan maybe dia akan lalu sikit, tapi mostly udara akan lalu dekat sini sebab tak ada halangan. But when the plunger, ini yang kita panggil as plunger, yang extra rod ni, when it enters to the apa benda ni, cap. So dia ada satu cap, so dia masuk dekat sini. So what will happen? The main door is closed, sebab dah tertutup because your plunger enters here. So what will happen? Dekat sini ada udara lagi. Ada udara lagi. So dia tak boleh escape dekat sini. So this ball will only move up when air is entering through here. Okay, in the one way lah. So only when the air want to extend the cylinder. Keluar tu dia still akan tertutup. So jalan dekat sini tertutup, jalan dekat sini pun tertutup. So it only have one way dekat sini. Okay, so one way to enter. So udara, semua udara yang ada dekat sini, dia akan enter through this shortcut. So shortcut, so it's depending on the screw. So kalau you nak dia escape lagi cepat, so you release the screw lah, but make the screw to go down. Okay, to go down. Okay, and okay, when the air is entering here, so plunger ni dia akan slow down. Dia akan slow down sebab dia ada another air flow dekat sini. So dia macam angin lintang lah. So when you have angin lintang, so you will have rintangan dekat sini akan, so the resistance will increase. Okay, so the air enters here. So as long the air enters, so yang ni dia akan slow down. Kalau yang ni you dah tutup penuh, yang ni pun dah tertutup, so the air cannot escape anywhere. Then you will have problem. So normally we will not close this fully. You still akan buka sikit. Faham tak macam mana cushioning happens?
So you're gonna concept air pressure.
Yeah. Okay, so I think you boleh answer question ni. How cylinder cushioning is done in a piston. Then the second question, what it means by deceleration characteristic? Yang ni I think ada dekat sini lah. Okay, boleh tengok dekat sini. So deceleration characteristic. Apa tu deceleration characteristic? Anyone?
That means it allows the air to is flow to decelerate through the piston.
Okay, so generally what it means by deceleration characteristic, so anything that help you, any parameters that you control for the piston to decelerate. Okay, so if you see here, so this is actually talking about the adjustable needle ataupun throttle valve. Okay, so this adjustable needle is to control the escaping fluid at the given rate. So like how I say earlier, if you tighten the screw, the space will be smaller. Okay, the root will be smaller. So the escaping air will go out at a very slow pace. But if you open and you unscrew this, your rate of deceleration will decrease and the air will be escaping faster. Okay. So the deceleration characteristic in this case is referring to the adjustable needle. You are adjusting. So what you are adjusting here? By adjusting the screw, you are adjusting the rate of escaping fluid ataupun flow rate. Okay. So deceleration characteristic for cushioning is the flow rate. Okay. So you are actually referring to the flow rate. So all that contributing. So whatever characters or parameters that help you to decelerate. Okay. Do you understand? So any further
Understood,
question?
sir.
Okay. Then we move to the third question: how the degree of freedom can be increased in pivot mounts. Okay, so this is on the mounting. A pivot mount. So you are putting the inch at the center of the body. So it can move upward and downward. Okay, so yani this is actually 2 degree of freedom. 2 degree of freedom means it move up or downward. So the question is asking how the degree of freedom can be increased in the pivot mount. So
Using universal joint.
using universal joint, so you can have one way you can have multiple pivot mount. Okay, or you can have a rotational platform or linear platform which can give you additional. So meaning it can rotate upward and downward using the pivot mount, and it can also move sideways. So it will give you 4 degree of freedom: upward, downward, left and right. So you just increase a universal. You can use a universal mount, or you can use a multiple pivot mounts, okay, which can give you a better degree of freedom. Okay, macam you tengok in robot. So robotic arm. So let's say let's imagine your own hand lah. Okay. So can you move upward and downward? Tangan you boleh move upward downwards? Boleh?
Yeah, okay, right.
Siapa tak boleh angkat tangan upward? Semua boleh kan? So upward is 1 degree of freedom, downward is another degree of freedom. So you have 2 degree of freedom moving upward and downward. So can your hand rotate to clockwise or counterclockwise?
No, there's a limitation.
So you have limitation, but you still can rotate, right?
Yes, sir.
So you have another 2 degree of freedom. So the same end can move upward, downward, and it can rotate clockwise and counterclockwise. Can you move your end right and left?
Yes.
And can you do all the thing together?
Yes.
So you have 6 degree of freedom in you. Actually, human hand can even move diagonal. uh, Diagonal. So so how to say? God has created us to function in multi-dimensional or multi-degree of freedom angles. Our especially our hands. So we can move more than 6 degree of freedom. Actually, we can perform better than robot. So that's why we can plus we have our intelligence, so we can decide. But robot it has a very limited ability to decide. Okay. That is what we call as a degree of freedom. So if you can move upward, downward, you can rotate and you can move sideways. So normally we will achieve a six, at least a 6 degree of freedom. Okay. I think that's on the question. Okay, so the next question, why power during extension and retraction of cylinder are the same? I think I bagi tahu tadi. Okay, so why power at the extension and also retraction are the same? Walaupun you ada the area is not the same. Anyone? Anyone can try? I think I ada bagi answer tadi.
Because both formulas for powers are the same.
Huh?
The formula for power is the same, right?
Formula is not the same because here you are using AP, piston area, here you are using AP minus AR. So the formula is not the same. I mean the derivation. But it says that the power during extension and retraction is the same. How to answer this?
Because the amount of power needed to push the piston would be equivalent to the power needed to retract the piston.
Yeah, that's the question. Why? Why is the same?
Because the volume flow rate entering same.
Okay, so it's the same. Okay, true. Actually, you can just answer based on this formula. So if you see here, the extension force and retraction force, uh, is it the same? So you see here is not the same because here you have pressure times area. So the area is not the same. So here the force are not the same, and the velocity also not the same. But once you join this, you have this formula. Can you see my cursor moving?
Yes.
Okay. So here you have P times with AP times Q in over AP, and here you have P times AP minus AR times with Q in AP minus AR. Actually, the power is the same because the area of your, so this is for your force and this is for your velocity, so it's cancelling each other. So the area is not the constant because it cancel. So no matter uh, what area you are giving here, so it will cancel each other. And at the final power calculation, so only the component of pressure and also flow rate is taken into consideration. So without considering how much how the area is covered. Okay? So you can answer this question by saying that so the area of the exposure will be cancelled out, and at the end only the pressure and also the flow rate is used to calculate the power. Boleh tak? Okay, can? So we move to the next question. Why the torque is double in double vane limited rotation actuator?
Is it because it has double the piston?
This is similar like the tandem cylinder, if you still remember. Okay. The previous lecture. Okay. Similar concept. Similar concept, but this is for linear. Okay, so for linear, you have two rooms, and the force, it produces a larger force. Okay, for linear, we call it as force, and for rotational, we call it as torque. Okay, so it says that it gives twice the maximum torque output of a single vane. So if a single vane can produce 10 Newton of force, double vane can produce 20 Newton of force. So that's what we mean by double. Okay, so the question is asking why the torque is double in double vane limited rotation actuator. Kenapa? Okay, if you compare dengan tandem, I think I have given the answer during the lecture last time. Kenapa the torque is double up? Anyone? So if you really listen to my lecture and follow, you can answer. Dia mesti ada satu sebab. So all the questions that you cannot answer, I boleh consider bagi dalam apa exam kan. Okay, so anyone? So try to think. This is application subject, so you need to like try to.
If there's two halves, so that it affects both.
Okay?
It affects both halves. Is that it?
No, I can't hear you. I
Is it
can't hear you.
because it it affects both halves of the double vane?
It's okay. I think that's correct. But what technically is happening? Okay, so I will give you the answer. So the force, I think previously also we have seen in the calculation, force. Force is related to the area of exposure. Okay, so in the double vane, you have two sides of vanes. So the force is applied to twice the area of a single vane. The single vane, dia cuma kena dekat satu side. So let's say it's only 10 centimeter square. Here it will achieve at 20 centimeter square. So based on the calculation of the force, when the area is double, your force pun akan double. So double vane produce twice the torque of a single vane because it has a larger or bigger area of exposure in the vane. Okay, that's why the torque is double. Okay, boleh? Okay, ada soalan? Okay, so we have two more questions. Okay, what is the function of rack and pinion in rotary actuator of rack and pinion type? Okay, rack and pinion. Apa function rack and pinion? So yang ni adalah rack, yang ni adalah pinion. So, apa yang dia buat dalam rotary actuator?
Convert linear to rotary force.
Yeah? Can you repeat?
It converts rotary to linear force and vice versa.
So it's actually a rack and pinion. So you can see here. You can see here clearly. So when the compressor enters here, so your rack will move to the right hand side. When it moves, it's a linear movement, but is attached to the gear, which is the output pinion. So this is rack, this is pinion. So when the rack move to the right, it will start to rotate. So kalau dia bergerak ke kanan, yang ni dia pusing clockwise ke counterclockwise? If the rack move to the right.
Moves to the right.
So if move to the right, it will be ikut jam atau lawan jam?
Equal jump clockwise.
Clockwise. Because you can see the gear will be moving to clockwise. So similarly, if you supply the air from the right, it will move to the left and it will turn clockwise. So what actually this rack and pinion does in a rack and pinion type of rotary actuators is actually convert translational to rotary movement. Okay, so the function of rack and pinion. Okay, rack and pinion you akan belajar dalam gear juga. Okay, I don't know whether you all ada belajar drive tak? Static.
As in what, sir?
Yeah. So I tak pastilah dalam syllabus you ada ke tak. But normally you will see this rack and pinion type in gears. Okay, macam dalam kereta lah. Okay, so but in pneumatic, this is how it functions. So rack and pinion is actually converting translational ataupun linear to rotational. Okay, so understand? Okay,
I
so,
understand, sir.
okay, we move to the last one. Okay, for today it's already 11 o'clock. How to change direction of rotation in helix spine rotary actuator. So helix spine, how to change the direction? Dari clockwise ke counterclockwise.
Supply from different ports.
So you just invert the ports. So if you want it to rotate counterclockwise, compressor must be entering through counterclockwise port. Okay, so in helix spine rotary actuators, normally the port will be named with a CW or CCW. So if you want it to turn counterclockwise, you just attach your compressor to the to this side, and if you want it to rotate clockwise, you just attach to the left hand side. Okay, so that's how you can change the direction of helix spine rotary actuator. Okay, so I think we have covered around 8 questions today, and we also covered on the remaining of chapter 3. Okay, so all these are very fundamentals. So if you read your lecture note, I think you suppose you can understand. And you also can refer to my recording, which today's discussion also I will upload in YouTube. I will give you the link. So all the links I will put in the respective topics in your Google Classroom. So just pergi dekat sana, all the lecture note, all the videos, everything will be there related to that particular chapter. Okay, so you just need to understand lah, so understand and learn. Okay, because nanti kita akan ada midterm. I akan bagi tahu bila midterm examination. So all these questions are potential to come up. Okay. So any final question before we dismiss? So tomorrow we will chapter 4. Yeah, I think the lecture note already available in Google Classroom. So if you want to print out download, please do so. Okay, so later kita akan ada uh, lab for group 1 ke? Group 1 if I'm not mistaken. Okay, so 2 to 4. So those, please prepare your presentation. Okay, so that you will present. So it's optional. So kami tak paksa anyone to present. If you want demo mark, you can present. So 1 to 2 minutes. 1 to 2 minutes. So just a simple. So present the circuit yang ada dalam lab module, not the exercise I bagi last week or 2 weeks ago. So I think that's all from me. So we will still remain online for some time until situation become better, until we can dapat the next instruction. Until then, maybe this week and next week I set for online dulu. Then we will see how. Okay, so thank you so much. Okay,
Thank you,
so
sir.
no further question, we can dismiss.
All right, thank you, sir.
Thank you, sir.
All right, thank you, sir.
Thank you, sir.
Thank you, sir.